Our planet has a story to tell, a really, really old story, and it's written in its rocks, its water, even its ice. So today, we're going to meet the scientists who can actually read that story. We'll look at the huge role they play in understanding our oceans and, maybe most importantly, how they help protect our planet's future. Okay, first things first. Who are these investigators? The ones uncovering these incredible stories hidden deep within our planet's chemistry?
They're called geochemists, and you can think of them as part forensic scientist, part historian for the entire Earth. They analyze the chemical makeup of, well, pretty much everything, from deep-sea mud to ancient glaciers, to figure out how our world works and how it all got put together in the first place.
And this is basically their toolkit. They analyze seawater to get a snapshot of what's happening right now. They look at biological stuff like corals or even fish bones to see how marine life is being affected over time. The elemental composition tells them which chemicals are present. And those isotopic signatures? Those are the real game changer. They act like a unique chemical fingerprint, letting them trace a pollutant right back to its exact source, whether it's a factory, a farm, or a city. And these sediment cores, they are absolutely the key to unlocking the past. Seriously, you can think of these things like history books buried at the bottom of the sea. By drilling down, scientists can read layers that go back thousands of years, giving them these critical insights into past climates and how our oceans have changed over all that time. And really, it all comes down to understanding the planet's most basic systems. Geochemists are experts in tracking these huge chemical cycles, carbon, nitrogen, sulfur, that are basically the lifeblood of our world. They keep an eye on the delicate balance of seawater chemistry and are often the first to sound the alarm on major issues like ocean acidification. Now, this brings us to a much more urgent part of the story. Because for all of Earth's natural cycles, there's a new, really powerful force at play. And that's the human footprint. To put it simply, we are changing the fundamental chemistry of our oceans. The systems that have been in a delicate balance for millennia, they're being seriously disturbed. And geochemists are the ones on the front lines, documenting the true scale of this change. From industrial and mining waste to the fertilizers washing off our farms and the runoff from our cities, we're introducing this whole cocktail of contaminants into the water. This table here kind of breaks down some of the main culprits. You've got heavy metals like lead and mercury from industry that work their way up the food chain. Then there are excess nutrients from fertilizer runoff, which cause those massive, nasty algal blooms that choke out all of the oxygen. And of course, there are things like oil spills and even microplastics, which acts like tiny little taxis, carrying other toxic pollutants all across the ocean. But here's where it gets even more, well, complicated. A lot of these pollutants don't just hang out in the water. They actually attach themselves to tiny particles and settle on the seafloor, where they get hidden away in the sediment, essentially creating a chemical time bomb. This leads to this really dangerous process called bioaccumulation. Here's how it works. A small fish absorbs a tiny bit of a contaminant. Then a bigger fish comes along and eats 100 of those little fish. And so on, all the way up the food chain. By the time it reaches top predators or even our dinner plates, that contaminant can become super concentrated, posing a serious risk to both wildlife and us. So we've identified the problem, and we've identified the culprits. But this isn't just about documenting a disaster. No, this science gives us the tools we absolutely need to build a sustainable future for our oceans. And all of this work connects to a really important global commitment, which is represented by just one number, 14. What does it stand for? Sustainable Development Goal 14, Life Below Water. This is one of the United Nations' biggest objectives, to conserve and sustainably use the world's oceans and all of its marine resources. So how does our chemical detective help make this happen? Well, they identify the pollution hotspots that need urgent help. They track contaminant levels over time to see if our cleanup efforts are actually working. And they inform. They provide the hard scientific data that governments need to make smart decisions about protecting coastlines and fisheries. And that right there is the ultimate takeaway. This isn't just science for the sake of science. It's about providing the clear, unbiased evidence we need to make good choices. Geochemistry, literally, gives us the map to navigate our way towards healthier oceans. The work of these scientists shows us that everything we do, every single thing, leaves a trace. The Earth is constantly recording our impact in its chemical signature. So the question we're all left with is this: When future geochemists look back at our time, what story will our chemical record tell them?